Hello, so we are back, and this time we have a nice laptop to repair. This is a Lenovo i5 ThinkBook. So this job is coming from a computer shop. They said they seen a blow up chip and they sent me the chip for replacement. So I will say let's open. Here are no screws. Yeah, we can open this easily. Beautiful. You know what? I love laptops. They have the screws are stuck on the case, so they are not falling down. You can see the screws. Yeah. Yeah, that's a nice motherboard, like usual. So where is that chip? Hmm? I'm assuming it's a power supply IC, and most likely somewhere here or on the other side of the board. Okay, let's try to take the board out to figure it out where is that chip, where that chip has to be. I mean, that chip most likely it's a power supply IC, and in that case, the output can be shorted. So I will say let's check the coils first before we are moving forward. Good, 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 good. 0 ohms. So probably the chip. Ah, yeah, I found it. I found it. Let's have a look at the chip. Let's see. Yeah, that's a proper blow up chip. I mean, the story is like that, yeah? If we are removing the chip and the short is gone, yeah, we can fix it. Even if the pins are welded, you can see the pins are welded based on the color. But if we are removing the IC and the short is still there, means whatever is on that power rail is shorted. So let me use some Kapton tape just to avoid taking the board out, making the job quicker as possible. Because if it's still short, we're not gonna be paid. So yeah, let's keep it short. Yeah, like that. And the chip is welded. Chip position, okay. And the layers are burnt, you can see. But that's not a problem, like I said, it's not a problem. The problem is if the coil is still shorted. The coil, 9 ohms. Lol. I mean, I'm assuming it's the chipset power supply, and 9 ohms is kind of low. So you see, this is a case where it's not great, it's not terrible. You remember the movie, yeah? And when it's not great and it's not terrible, it's you are in the middle. So can be good, can be bad. But let's try and lower the voltage and see how the chipset is looking. I'm assuming it's a chipset power supply. I'm assuming. Hmm? The current, we have like 4 amps. Let's lower the current. Good. Let's see what current is taking here. It's taking like 110 milliamps. You know what? It is possible to be good. Huh. It is possible. Let me clean the chipset. So I think we have chance to fix this one. One more time. Yeah, there is like a hot area because we desoldered the chip. The chipset, I can't even see heat from the chipset. So who is taking? Something here is taking some current, just a little bit. No, I can't see anything on the chipset, so I don't think it's the chipset one. Can be the RAM memory? Do you think it's the RAM? That's not even important right now on this point. We have 9 ohms. Before we are deciding, yeah? Let's try to simulate that power supply, yeah? So we're gonna learn how to simulate a working power supply. Also trying to find the right voltage on that power rail. This is an Intel CPU, yeah, it's i5. Good, so we need a charger, USB-C charger. No, I'm not gonna plug the battery. And the meter, it is coming on. Boy, it's taking like 5 volts. Okay, that's bad. Pressing the power button, nothing happened. That's proper bad. But let's see. Let's see. I need a proper ground. Proper ground. Yeah, that's a proper ground. Unplugging the USB. It's taking 100 milliamps. Plugging the USB, and nothing happened. I mean, no picture. No, the meter is not coming on. Now it is coming on. And it's taking 5 volts, 100 milliamps. Yeah. Let's higher the voltage. No, it's too much. I'm assuming it's 1 volt. It's a 1 volt power rail. But still, the laptop is not working. Let me see if I can reset by the power button. I can't. Okay, let's find out what is taking 110 milliamps from the meter. And something here on the other side of the board is taking 110 milliamps. Let's check the main power rail. Maybe we miss something. So the main power rail is not shorted, it's fine, but has no voltage either. Plug in the battery, plug in the charger. Now it's taking like 500 milliamps. Do you think actually it's charging the battery? Or why it's taking 500 milliamps? Now we have 0 volts on the battery. Okay, let's higher the voltage. Let's try to charge the battery. And the battery is charging fine. Check that. Like 2 amps. 9.6. Let's higher the current. Yeah, 2.8 amps. Okay, so now the battery has some voltage and some current, right? Good. And the meter is not coming on anymore, not there. 5 volts. Nearly no current. Pressing the power button, we have the orange light here flashing. Check there. Huh? I mean, you know what? It is possible. Okay, the power supply is blow up. It's fine. That's not a problem. It is possible. Like, the laptop has a input charging circuit issue, leaving on one side this chip. So what I'm looking is to start the laptop with the battery power and see if it's working. Because even if, the charging circuit has an issue, it should work on the battery. Now, if it's working on the battery, we're going to simulate that power supply, 1 volt, and we'll see if the laptop is working. If it's working, we are moving forward, diagnosing the charging circuit, the PD controller, actually. Let me charge the battery a little bit. Yeah, 3.5 amps. Okay, let's try to power on the laptop. Pressing the power button and it's still flashing. Let's simulate a charged battery. Pressing the power button and it's still flashing. Yeah, we cannot fool the EC chip. Actually, the battery is charged. Or maybe the battery is charged. Yeah, it's working. It's coming on. Check there. Yeah, so we fool the EC chip. Actually, the battery is charged. And it's coming on. We know picture, obviously, because the voltage is missing there. Yeah, you can see the orange light here. Yeah, it's on. Let me switch it off. Good, now it's off. Let's lower the voltage. 1 volt. Now let's power on the laptop now. Yeah, it is coming on. It's taking like 60 milliamps. We have picture. We have picture. What was saying? Was saying error, right? Yeah, so that power supply is 1 volt power supply. And the laptop switched off. One more time, it's coming on, the fan is spinning. Low battery error. Okay. So you understand, without this 1 volt, the laptop, it will not work. So you see the LED is off. Pressing the power button, it is coming on, but we're not going to see anything on the screen, like that error. because the chipset doesn't have what? We do have pictures, so this is not a chipset power supply. Then it's not 1 volt. Now I'm confused. Now I'm confused. So what is it then? Schematic? No, we don't have schematic. No. I mean, based on the location, I would say, yeah, probably it's 3.3 and it's supplying power to the, M2 slots and more things. But it's not, because if I go with the voltage up, start taking too much current. So it's not 3.3. And probably it's not 5 volts also. Okay, we need to find out what that power supply is doing. 5 volts, let's raise the voltage. Yeah, like 2.4 volts, and it's taking 220 milliamps. And what is taking 220 milliamps? Check that. It's exactly the same chip. Oh wait, that chip is still, it's sucking power from the battery. Don't worry, we're gonna find out soon. So supplying power here, and exactly the same chip is taking current, even from this coil. So what is that chip? That's my question. And even if I plug the charger, exactly the same chip is getting hot. 500 mil. Check there. I mean, with the charger plugged in, that chip is getting hot. With the power coming on this coil, that chip is getting hot. If I plug the battery, same chip is getting hot. So we can assume that chip is dead. Yeah, 100%. So let's take out this board, because we have some chance to fix. We see picture on the screen. Yeah. So we know CPU, chipset, EC chip, everything is good. So we do have some chances here. I'm optimistic. So you see, we follow basic diagnostic, no schematic also. And that's how we are diagnosing things without a schematic. When you have a schematic, it's easy, you just go on the schematic, check the voltage, you can see on the board view what is there. It's easy. Can we find a schematic? Probably we can find a schematic. Probably. But searching for the schematic, buying the schematic, then spending some time to figure it out what's going on, is kind of, for me, it's shorter just to, go blind and try to figure it out myself. And also it will keep your, your brain alive. Like morning exercise, it's about 9 o'clock in the morning. So the board is out, and the chip on the other side is the PD controller. Exactly here is this small little prick. So the little prick, it is the PD controller. So the voltage on the coil can be 1.8 or 3.3. And this is speaking with the EC chip and so on. Yeah, that sucks. TPS 65994. You know what? I'm pretty sure this has to be programmed, right? From what I remember. So the chip is not creating the main power rail. That's the problem. The chip is getting hot also, yeah? So it's taking like 110 milliamps now. That's strange because it was taking like 500 milliamps. Huh. So it's not taking 500 anymore? So what changed? We just took the board out, nothing else. Do you think something else can be shorted on the laptop? Yeah, but the chip is still getting hot. I mean, even with 100 milliamps. But I want to know why it was taking 500 before. Because we have a shorted output from that chip? Can be. And you know which output is shorted? The one with 9 ohms. Probably 9 ohms is coming from this chip. But let's see. Here we have nothing. Fine. 0. And we have like 2 ohms here. And I don't think that's right, 2 ohms. Here you have 9 ohms. Check that. Huh? Let me bring this on focus. 9 ohms. You see? Here is ground. Here is 9 ohms. So the 9 ohms is because the chip is partial shorted. Yeah, it is possible to have this chip, TPS 65994. Let me check. Let me check here. Not sure if you can see. I found the chip. Yeah, so we have a spare chip. So I'll say, let's take this out. Replace the chip. What do you think? A little bit of liquid rosin. Just a little bit. And the chip, it's out. Check that, we left the solder balls perfectly. Just a little bit more of liquid rosin. So we don't need like repolling. Now let's take out the other chip, which is here. Same liquid rosin. Yeah, the chip has a crack on a corner, but that's fine. Better cooling, huh? Probably it's dead, but yeah, let's try it. At least it's not shorted. Perfect. So pin number 1 is there, and we are moving the chip here with the pin number 1 here. Yeah, but that should be okay. You know, this is a brand new chip, huh? Perfect. Let's solder the chip back. We have to put the chip exactly on the middle. You know what I mean? Because we have the solder balls there. Yeah, let's try now, yeah? And the chip is moving, yeah, on his place. Perfect. So what do you think? Perfect solder. Check the solder balls. Check the solder balls on this side. Perfect. So what do you think it'll gonna happen if we are plugging the charger? Your opinion? Perfect. Let me plug the meter to see actually if it's working, if it's negotiating the voltage. The meter is coming on. 5 volts with no current. 5 volts with no current. Okay. I'm not sure if this is good or bad. I mean, it's not taking current anymore, so the chip is not getting hot. It is possible to not negotiating the voltage because we have this power supply which is mixing. But let's check the resistance of this power supply. So the coil resistance, it's infinite resistance, yeah. So the 9 ohms was because of the shorted chip. You know what I'm gonna do? Because I'm pretty sure this power supply is very close related with the PD controller. Let's lower 1 volt. And it's taking nothing. Let's rise to 1.8. Oh, actually, let's try first with 1.8. With 1.8 volts, it's doing exactly the same thing, nothing. Then 3.3. Must be 3.3. Yeah, 3.3. And it's doing nothing. Kind of bad, right? And we don't know why, because the chip is cracked, because the chip has to be programmed, because this chip is missing. We don't really know. But I will say, let's solder this chip back. I think that's the way to go. Because we have the chip, and it's easy to solder the chip back. I mean, kind of easy. Kind of. Not sure how bad it's welded here. It looks bad. Well, let me come with a solder iron. It is possible this chip to provide also a second voltage. So in that case, just trying to supply power with the power supply on the coil is not helpful if the chip is providing a second voltage somewhere. So yeah, I would say let's solder that chip. Okay, Rossin flux. And yeah, let me come with hot air. Nah, it's welded. It's welded. It's nothing what I can do there. It's welded. Yeah. Yeah, that's all what I can do. Yeah, that's all. Nothing else. The solution is a proper dodgy calibrated wire there. And hopefully that it will do the trick. This broken track is one, which is providing 19 volts to that chip. Huh? Nice. Now let me grab a wire. Let's do like a roundabout there. Just to be sure the wire it will not goes away when I'm coming with hot air. I mean something like that. What do you think? Yeah, something like that. Perfect. Yeah, looks perfect. I don't really like this one. Yeah. Perfect. Okay, let's grab a chip. That's the chip, okay? I'm trusting the computer shop. I'm not gonna check what chip is there. I'm assuming they checked already. Yeah, you're right, the chip is looking pretty bad. I mean the pads on the chip. Like rusty. But we can't be wrong. No, we are wrong. So actually the chip is fine. Yeah. Perfect. Now let's solder the chip back. Pin number 1 is there, yeah? The pin number 1 has to be on this side. Yeah, like that. Perfect. It is perfect or not, huh? Just say it. We did a better job compared with the manufacturer. Yeah, probably. Let's see. Let's see. You know what? Let me switch this. Yeah. Yeah, better. Yeah. Now let's plug the charger and see if anything it will blow up. Plug in the charger and the meter is coming on with 4 volts. That sucks. That proper sucks. And the voltage there. We have like 0 volts there. Okay, let me plug the battery. Plug in the battery and yeah, it's not charging. battery had like 10.7. Here we have nothing. So what is happening? The PD controller is not working for some reason. What you said? My PD controller is faulty? Let me have a look for another one. Check here. We found a brand new chip. Brand new one. Looks like a brand new. Now we're gonna sell this like a brand new. Even this chip can be good. Can be good. Good. I'll put it on my box. We're gonna sell this chip as brand new next time. Solder balls, perfect. Pin number 1 there, perfect. Good. Perfect. Chip is moving. That means it's soldered properly. Lol. Pin number 1 is here. It's not good. They soldered the chip bad. You didn't see that, right? Can happen. Can happen. Good. Perfect. Perfect. Yep, all good. Let's test one more time. Plug in the charger. $19. That's crazy. It's working. Oh, we cannot sell that chip like brand new. What is it? Okay, just remind me next time I have a faulty chip on this box. 19 volts. Plug in the battery. We have the charging light. 300 milliamps, and probably the current is going up soon, hopefully. Let's check the voltage on that coil. 1.3 amps, 1.3 amps. And the voltage on the coil is 5 volts. Check on the screen, 5 volts. It's working. So it was a 5 volts power supply. So if you have this chip, looks like doesn't have to be pre-programmed. You know, I'm happy I helped this customer. Luckily, I find this chip because I checked on eBay, and on eBay it's like £15 this chip. So check here, yeah? Check here. I will switch 1 second. PC screen, check here. Like £16, the cheapest one. Crazy, it's quite expensive. Let's put the board back. Okay, let's see. Plug in the charger, the meter it is coming on. We just put few screws just for testing. 1.3 amps, and we have the orange light. Pressing the power button, and the current goes up to like 2.2 amps. You can see 2.3 amps. We reset the BIOS, yeah, because the BIOS is on this board, the battery BIOS, so we disconnect the cable, so we have to wait a little bit. But I'm pretty confident this, and it's working. We have picture. Do you see Lenovo? Yeah. And what is saying? Yeah, it's trying to boot. I mean, we can plug the hard drive, but you know, this is important. The current, you can see the current is like what, 2.7 amps, yeah, which perfectly fine. Everything is working fine. Yeah, no boot device. Okay, let me power off. Let me plug my hard drive, my SSD. Oh. SSD is plugged in. Pressing the power button again. Let's see. What is that? System update? That didn't look like a system update. It looks like a, you know, PD controller software firmware update. And it's loading the Windows. Yeah, all good. It's working fine. Perfect, huh? Yeah, fully working. Yeah, we do have the charging sign there. All good. Now let me unplug the charger. Let me unplug the battery. And let me take out my SSD. It was a hard job. Kind of. Yeah. We spent some time here. I mean, if you look like for the moment, we kinda lose time. We charge like half money because it's coming from a computer shop, so not really worth it. I mean, we spent probably like over 1 hour. But you know, if you just step back and you look at the big picture, we learn a lot of things. Yeah. On the next laptop, we know. On the next same model, we know the PD controller can be replaced without programming. We know this power supply is a 5 volts power supply, and yeah, that's a lot. Yeah. Okay, so I'm gonna stop here. I'll say thank you for watching. Saturday, have a beautiful weekend, and see you on the next one. Bye. Hey, if you find my content being helpful, don't forget you can support this channel by pressing the join button, and you can get instantly access to our members only cool collection and Discord private channels for support with your repairs. Also, you can have a look on our United Kingdom eBay, where you can find some cool and unique products, United States eBay store, or our Patreon page. Thank you.